Hello everyone, welcome to Cambridge Guru. We are at the last topic of chapter vectors, and in the previous video we covered the topic uh, angle between two lines, right? In the next video, means this video is about finding out the perpendicular distance from a point to a line. You will be given a line and a point, and you have to find out the perpendicular distance of that point to that line, right? So let us start, and we straight away understand the concept by taking an example. So it says that we have to find out the shorter distance from point P, this is the given point, to the given line L with the equation 150 plus lambda times minus 3, 1 and 4. So let us understand what is the concept and basically how we will find out this. So let us say we have been given a line, straight line, and this line, as it says, is L. Okay, and there is a given point P whose position vector is given as 11 minus 5 and minus 3, right? Basically its coordinate is given. We are denoting this with P, right? And let us say that there is the perpendicular distance is denoted by NP. Okay, and where is N? N is the point of intersection of this perpendicular to the line L. I'm calling this as point N. Okay, so basically what we have to find out is the shortest distance. As it says the shortest, so we will say that the perpendicular distance is only the shortest distance, right? If you take any other distance, for example this distance, right, this is also the distance, this is also the distance. Okay, so if it talks about the distances of a point from a line, you will get infinite number of distances. But as far as shortest is concerned, so the perpendicular distance will be the shortest distance. Okay, so we will omit all these green lines and we will consider only the perpendicular line from P to N. So basically we have to find out NP. Just a minute. What we have to find out is NP vector and its magnitude, right? Since we are interested in finding out the distance. Okay, so how we can apply the concept what we have already learned. Okay, since this given line L is given and its equation is given, so any point which is lying on this line will have the position vector given by the equation of the straight line. That is the meaning of vector equation of a line, that it gives the position vector of any point which is lying on this straight line. Okay, so if I'm talking about the point N which is lying on the line, so I will say that the position vector of point N denoted by ON is 1 plus minus 3 lambda and 5 plus lambda and 0 plus 4 lambda. So this is the position vector of a point N which is lying on the line L. Okay, for some value of lambda. You can take some value of lambda as, or you can replace this lambda as T, right? That at this particular point where this Pn is perpendicular to L, this value, this scalar lambda is having some value, let us say T. So in that case, you can replace this lambda with T, but I am not replacing it. I am just saying that since for some lambda, I will call this as a position vector of N such that this is perpendicular to line L for some value of lambda. Okay, so let us consider that value as lambda. Why we introduce another variable in this. Okay, so we have now the position vector of N. Now it says that this NP is perpendicular to line L, right? If means in the last video, or I think last to last video, if I am talking about the angles between two lines, then we will only consider the direction vector. Okay, so if I take out the dot product of this vector On, that means On dot this direction vector which is minus 3, 1 and 4. Okay, this direction vector minus 3, 1 and 4, as this gives the direction of the given line L. So if I take the dot product of this with On, right, that should be 0 because these two lines P and NP and vector L are perpendicular. Okay, So I'm taking the dot product with -3, 1 and 4. The answer I should get is 0. Okay, so now on is in the terms of 1 or it is in the terms of lambda. So let us write on in terms of lambda such as 1 plus, not plus, it is -3, 1 minus 3 lambda, 5 plus lambda and 4 lambda dot -3, 1 and 4. This is equal to 0. From this I get -3 plus 9 lambda plus 5 plus lambda, and this is 16 lambda. Okay, this is the dot product of LHS and this should be equal to 0. Okay, reason being that ON is perpendicular to NP. Okay, so from this let us find out the value of lambda. It is 16 plus 1 17 plus 9 is 26. Lambda is -3 plus 9 and 5 plus lambda plus 16 lambda. 17 plus 9 is 26 lambda. This is plus 2. Okay, -3 plus 5 is plus 2 equal to 0. So from here I get value of lambda as -1 over 13. The moment I get lambda as -1 over 13, I can put this value of lambda in vector On. Okay, the moment I put this, I get vector On as 1 minus 3 lambda. So this is 1 minus minus is plus. So this is 3 by 13. Then 5 plus lambda means 5 minus 1 by 13. And lastly, it is 4 lambda means -4 over 13. Simplifying this, I get 16 by 13. This is 64 by 13. And lastly, it is -4 by 13. This is your vector On. Right, and I'm interested in finding out the magnitude. So On magnitude is 16 by 13 whole square plus 64 by 13 whole square and plus -4 by 13 whole square. Okay, so this and square root of this, right? And this is 16 square is 256 plus 64 square, and I don't have the calculator with me, so 64 is basically 2 raised to power 6, so it is 2 raised to power 12. 2 raised to power 12 means 2048 is 2 raised to power 11, and into 2 will be 4096, so it is 4096 and plus 44 is 16. Okay, divided by 13 square, right? So 6 plus 6 plus 6 is 18, carry is 1, 6, 9 and 6 is 15, plus 1 is 16, then carry 1, this is 3 and 4. So square root of 4368 divided by 13. This will be the, I'm not interested in finding out the exact value of 4368. Okay, you may use the calculator, but if the calculations I have made are correct, then this will be the perpendicular distance. Okay, so I'm again repeating the steps. What you have to find out in order to calculate the shortest distance of a point, a shortest distance if from a point on a line is that you first find out the point where this straight line joining the given point and the point at which the shortest distance will intersect the given line, right? Name this point as n. You first find out the position vector of the point, right, in terms of lambda, and then apply the dot product of vector np with the given line, direction of the given line, and from here you will calculate the value of lambda, put that back into the equation, not the equation, into the in the vector or np in place of lambda, find out np and then calculate its magnitude. Okay, so that's all for as far as chapters vectors are concerned. And again, I'm repeating that please like, share and subscribe my channel, and please subscribe my Telegram channel also. And if you need any video regarding, if you want to discuss some past papers, then please mention in the comment. Okay, any particular video, any particular assignment you need to concern, or any question that you want to discuss, or if I am able to solve that question, then please write in the comment section. Okay, so that's all for today, and see you with the last chapter soon, which is complex numbers. Till then, goodbye, take care.